Okay, this question is going to look at tutorial 3A, question 6. Tutorial 3A, question 6 gives us this graph, tells us that it's got the equation y is equal to x plus a squared over x plus b. Part 1 wants us to find the values of a and b. The first thing that you notice is that there is an asymptote at x equals to minus 2. So when x equals to minus 2, we know that the bottom line has to be 0 because that's what gives us an asymptote. And so therefore we can say that b has to be 2. How about finding the value of a? Well, to find the value of a, you need to know that the curve passes through the point. It has a stationary point at 1, 0. In particular, that means that it passes through the point 1, 0. So therefore, substituting x equals to 1, y equals to 0 in this equation, you get 0 is equal to 1 plus a squared over x plus 2. Move that up, you find that 0 is equal to 1 plus a squared, and therefore a has to be negative 1. Part 2 asks us to find the equation of this asymptote L. So remember, now we know the equation of this line. This is y equals to x plus 1 squared. Sorry, not x plus 1, x minus 1 squared over x plus 2. So to find the oblique asymptote, usually what we do is long division. So we take, I'm going to expand this out, I get y equals to x squared minus 2x plus 1 over x plus 2. Now what happens if I take x squared minus 2x plus 1 and divide it by x plus 2? Well, first is x, then I'd get x squared plus 2x. I would get minus 4x plus 1 minus 4. Get minus 4x minus 8. And that leaves me with 9. Remainder of 9. So this is the same thing as x minus 4 plus 9 over x plus 2. So we know as x gets closer and closer to infinity, 9 over x plus 2 is going to go to 0. So as x tends towards infinity, plus or minus infinity, y is going to tend towards x minus 4. So therefore the equation for L is y equals to x minus 4. Part 3 wants us to determine the coordinates of this turning point P. Now we could do this by differentiation. However, we should also recognize that a hyperbola is symmetric about its center, and in this case its center is going to be the intersection of these two asymptotes. In fact, that's always going to be the center. So what is this coordinate? Well, this is obviously has an x coordinate of negative 2 because it lies along the line x equals to negative 2. And if you substitute negative 2 into here, you find the y coordinate is negative 6. So the first turning point, you go from 1, 0, you go down 6 across 3. So this one's also going to be down 6 across 3. The turning point for P is going to be minus 5 minus 12. Part 4 asks us to copy this sketch and then draw a sketch of the curve x squared plus y squared is equal to 16, or in other words, x squared plus y squared is equal to 4 squared. We know that this is the equation for a circle with radius 4. So what's that going to look like? It will have intersection points at 4 with the axes at 4, 0, 0 minus 4, minus 4, 0, and 0, 4, and it will be a circle. Now that's not going to look like a circle here because actually by right they haven't given us something to scale, but oh well. Hold on a second. Sorry, I just realized that minus 4, 0, 0 minus 4, sorry, should lie exactly here. So if I can delete that, yes, thank you. It will lie there. So that's 0 minus 4. Oi, what's going on? Okay, let's try again. Is that going to... Oh, you just don't want that. Okay, let's make that small and put that over to one side. So here, and this is going to be 0 minus 4. Good. Oops. Sorry, I hope that you guys will be able to draw this a little bit better than I can. This is a potato, but actually what it should be is, sorry, part 4, this is going to be a circle of radius 4 with center 0, 0. Part 5 wants us to show that this equation, 2x to the power of 4 minus 6x squared minus 68x minus 63 equals to 0, has exactly 2 real roots. Now the clue here is in the hence part of this question, so I know I'm somehow going to have to use this equation and the equation for my original curve, which was y is equal to x minus 1 squared over x plus 2. So I'm going to try just substituting this formula, this equation, into my equation for my circle. So put this on ice for a bit. So if I take x squared plus x minus 1 squared over x plus 2 squared equals to 4 squared, what do I get? I get x squared plus and times x plus 2 squared, moving the bottom line up, plus x minus 1 to the power of 4 is equal to 4 squared x plus 2 squared. Expanding that out, x squared plus 4x plus 4 plus this will be x to the 4, take 4x cubed plus 6x squared, take 4x plus 1 is equal to 16 x squared plus 4x plus 4. So what do I get? I get x to the 4 plus 4x cubed plus 4x squared, that's the first one, plus x to the 4 minus 4x cubed plus 6x squared minus 4x plus 1 is equal to 16x squared. 4 times 16 is 64. Okay, so is that going to help us much? Maybe. Let's find out. So I think you can, let's get a new page, come on. So we can still see it up there. If we simplify this one, we get 2x to the power of 4, this term plus this term. The x to the power of 3 term disappears. 4 plus 6, so I'm going to get plus 10x squared minus 4x plus 1, and I realize there should be an x in there as well, is equal to 16x squared plus 64x plus 64. So move everything over to one side. I get 2x to the power of 4 minus 6x squared minus 68x minus 63 is equal to 0. So what have I shown? I've shown that this equation has as many roots as points of intersection for these two graphs. So therefore, the number of roots to the equation is equal to the number of intersection points for the curves, and that's equal to 2. So therefore, 2 real roots. Just reviewing this question, I recognize one part where it may be a bit difficult to see what to do is how did I know to do this? Because usually what we would do is we would try and make this one into the right form. We wouldn't usually start like this. The reason I knew to start like this is because this form, it was basically too hard for me to do anything with, but I roughly know, because of the hence, that I'm going to need to link it to the points of intersection, that the number of roots, number of points of intersection. I see there are 2 points of intersection. Asked to show something has 2 roots. I can form the connection. So I expect that I'm going to try and have to show that this equation here comes from the intersection of these two curves. So that's why I straight away substituted in y into the equation for my circle. So that ends question 6.